Hello, everyone. This is Carl Freund, Cambrian AI Research, and I'm doing yet another interview here today. You might find very interesting. I've got Geoff Tate of FlexLogix and Dana McCarty, Vice President of Marketing of FlexLogix. I appreciate you guys joining me today. We call this series the Cambrian Visions, and so let's start there. Geoff, if you'd like to just elucidate your vision for AI and the role you see FlexLogix playing.
Oh, great. Well, thanks for having me, Carl. Vision for AI. Well, like everybody, we see AI as being a very fast, high growth market spanning from the data center down to extremely low power voice applications. And no one product is going to span the whole range. What our focus is on what we call the edge and the enterprise edge. And our customers are all focused on megapixel, high accuracy, high quality models using neural network AI processing, and that's our focus.
Good. Now, I notice in terms of your communications, one of the things that really struck me is efficiency and price. It seems like you're pricing this fairly aggressively to get deployment, hopefully mass deployment for you in the firm. Can you talk a little bit about your product and its role in fulfilling your vision for AI?
Yeah, there are a lot of people entering this market at different market segments. Our market segment's relatively uncrowded, but in any given market segment, the winner is going to be the person or the firm that has the most efficiency. Who can get the most performance out of the same amount of silicon and the same amount of power? Because customers in all of these market segments have constraints. There's only so much power they can dissipate and only so much money they can afford. So the GPU architecture has dominated, but the GPU architecture was never designed for inference. It's been adapted for inference very well by NVIDIA. But our architecture is multiple times more efficient than GPU in terms of getting performance of the same amount of cost and the same amount of power. So we're more efficient, so we can outperform chips that are much larger and more expensive than us.
Interesting. So what is it about your chip that makes it so efficient?
We have an architecture which uses two critically different, very unique approaches. First, most people have large tensor processors like in the original Google TPU. What we do instead is have a larger number of smaller tensor processors, which we can recombine to efficiently implement each operator as well as possible. But secondly, we use programmable interconnect. Everybody else is using meshes of networks on chips. The problem with networks on chips is only one processor or compute unit can be using it at a time. In our case, all of our compute units can be connected to memory directly in a non-blocking fashion using our programmable interconnect. So those two things give us much higher efficiency in using the hardware to get more performance and do it with much lower cost.
Interesting, interesting. Well, it seems to me that your product is fairly unique in the industry in terms of your architectural approach. Can you talk about some of the applications that you're currently exploring with your prospective clients?
Our clients that have contacted us are using AI across a wide range of applications. Many kinds of medical imaging, MRI, X-ray, ultrasound, for example, and many different price points. Factory automation and inspection, production lines, checking that simple things like there's all the cookies that are supposed to be in the box, which can be very important. Also autonomous vehicles from cars to farm vehicles, automation of various aspects of freight transportation. So we're seeing a wide range of applications that people are deploying AI in. And in all cases, they have a megapixel sensor that's picking up some part of the electromagnetic spectrum. And they're using AI either to do object detection and recognition, or in many cases to improve the image quality, among other applications.
So in some of those applications you just mentioned, they require multiple sensors. In your pipeline, where does sensor fusion take place?
In the only applications whether we have run into that have multiple sensors is autonomous vehicles,
Mhm.
whether that's a farm tractor or a car. And of course,
Mhm.
there are multiple cameras outside and inside. In all other applications, there's one ultrasound sensor. There's one electromagnetic sensor. There's one laser sensor. So in the majority of cases, there's one sensor and one model running at a time.
Okay, one model running at a time. Does your chip support being able to run multiple models at a time?
Well, yes, like when we say at a time, microprocessors do multiple things at a time, but of course, at
Mhm.
any given nanosecond, they're doing one thing and they switch rapidly between them. So our
Okay.
chip can do the same.
Okay, interesting, interesting. So what about timing? When could we expect to see you shipping into production? Do you have you have a crystal ball you can share with us?
Well, yes, we have products now. We'll be sampling shortly, and we'll be in production approximately late Q2 of this year for both our chip products and our board products with accompanying compiler tools.
Hmm. So as boards, I assume that's like a PCIe or is it something smaller?
The first is a PCIe. It's the half height, half length, so it's actually relatively small.
Hmm.
But we'll have an even smaller board, the M.2, in the summer timeframe for sampling. It'll be in
Good.
production later in the year.
Later in the year for the M.2. Interesting. Well, it sounds like you've got a very interesting value proposition. Um, I think efficiency is key in success for all edge applications because of power constraints are pretty severe. So it seems like you've got a pretty good shot at a unique value proposition in the marketplace. Any final points you'd like to emphasize or re-emphasize?
Well, you mentioned power is critical. So we have run into customers who want maximum performance, and our marketing materials have focused on that. But we've also found customers who are more power constrained and want good performance for less power. So we'll be talking in the next couple of months about lower power versions of our chip. They give high throughput per watt, but focused on lower power than what we've talked about to date to expand the market that we're able to support.
Yeah, that sounds like a next logical step for you. I look forward to hearing more about that and talking with you again once that technology has been announced. And also, welcome back anytime you'd like. Use this as a platform to talk about your customer design wins and what interesting problems they're solving because of the technology you're bringing to market. So, Geoff Tate, thank you very much for your time, and I look forward to talking with you again soon.
Carl, it's always a pleasure. Anytime. Thank you.
Thanks a lot. Take care. Stay well.